The observable universe is the part of the cosmos we can actually study using telescopes and scientific instruments. It shows us what's possible to see based on how far light has traveled since the beginning of time. But there's a limit to what we can observe. Light travels at a finite speed, so we can only see things whose light has had enough time to reach us. This wasn't just cosmic noise. This was a fingerprint of something far beyond our understanding. Google's most advanced quantum computing team took one look at the data and confirmed the impossible. What you're about to discover might change everything we thought we knew about the universe and reality itself. It all began with what was supposed to be a standard observation. The James Webb Space Telescope was scanning Able 2744, also known as Pandora's Cluster, a densely packed field of galaxies used for lensing studies. This region is perfect for detecting some of the oldest light in the universe. But within the sea of distant starlight, the Webb team began noticing something strange. It wasn't a missing star or a broken signal. It was a distortion, a diffraction pattern that didn't behave according to known laws of physics. Most light curves under gravity, especially when passing near massive galactic bodies. But this was different. The distortion appeared ordered, symmetrical. It didn't fade with distance, and most alarmingly, it repeated in places it shouldn't. Initially dismissed as a software artifact or imaging artifact, the anomaly persisted through every calibration run, multiple filters, different time exposures. Even when the telescope refocused, the anomaly remained embedded in the image data. Something out there wasn't just bending light, it was encoding something in it. And that's when NASA turned to a new kind of interpreter, not a person, not a classical algorithm, but a quantum system designed to find patterns where human logic cannot. That's when Google's quantum computing division entered the story. And that's when everything changed. Google's quantum AI team wasn't brought in to look for aliens. They were brought in to decode high-dimensional noise patterns buried deep within light signatures that traditional systems couldn't process. Their quantum computer, Sycamore, operated using entangled qubits, allowing it to consider not one solution at a time like a normal supercomputer, but every possible outcome simultaneously. It was given the raw Webb data. It ran for days. And when it returned results, even the most skeptical physicists were stunned. The quantum system had isolated a non-random pattern, one that matched theoretical predictions from string theory's hidden dimensions. According to these models, gravity might be weaker than other forces because it leaks into extra spatial dimensions, places beyond the three we perceive. And the distortions in Webb's light weren't just gravitational lensing. They were the visible side effects of this leakage, affecting photons traveling billions of years across folded, vibrating space. It's as if something outside our dimensional frame pressed its hand into the fabric of the universe and left a fingerprint of its structure behind. And that fingerprint mathematically aligned with brain-world models, the same concepts once dismissed as speculative fantasy. Webb, unknowingly, had taken a picture not just of galaxies, but of how the universe might truly be built from the outside in. For over a century, gravity has been the great outlier in physics. It's the weakest of the fundamental forces by far, billions of times weaker than electromagnetism or the nuclear forces. No one has ever truly understood why. But the new Webb data and its quantum analysis may offer an answer more radical than anyone anticipated. According to emerging interpretations, what JWST captured wasn't just gravitational lensing through space, it was gravitational bleeding into adjacent dimensions. Imagine our universe as a thin film, like the surface of a bubble. If gravity can flow into higher dimensions, it would weaken in our own. But in certain conditions, when the structure of those dimensions fluctuates or aligns, their presence could warp light, just like what was observed. That means dark matter and dark energy, those mysterious forces we've labeled out of ignorance, might not be things at all. They could be side effects, echoes, projections of forces originating in a greater dimensional framework. And for the first time in history, We may have seen that framework imprinted onto a photo from a telescope floating 1.5 million kilometers from Earth. It's no longer a matter of philosophical debate. It's data. Hard data. And while some scientists remain cautious, others are already speaking of a paradigm shift. Because if our universe is just one membrane in a higher dimensional space, we're no longer asking what's out there, we're asking what's beyond here. There's a cruel irony in all of this. The place where Webb first detected this anomaly, the galaxy field it was targeting, bears the nickname Pandora's Cluster. And now it seems the name was more prophetic than poetic. Because with that single image, accidental, routine, unintentional, we may have opened a door no one meant to knock on. The idea that our universe is part of a larger, more complex superstructure isn't just a fringe theory anymore. With every reanalysis of Webb's data, the quantum patterns become clearer. Peer-reviewed papers are already flooding journals. Research labs at MIT, Caltech, and CERN are shifting focus. And behind closed doors, defense agencies are reportedly examining the implications of higher dimensional space, not as science fiction, but as a framework for understanding reality itself. But there's fear, too. What if what we're seeing is only the edge? What if these diffraction patterns are just the signature of something else, watching back from outside our dimensions, from outside our rules? Because for all its power, Webb wasn't designed to look into other realms. And yet it might have, accidentally, in silence, without anyone realizing it, until now. And in doing so, we may have peeked behind the curtain of spacetime, only to discover that we're not alone, not in the way we imagined, but in a way we may never fully understand. For centuries, science has worked under a fundamental assumption that the universe is governed by fixed, predictable laws, that light bends under gravity, that time moves in one direction, that matter occupies space. But what the James Webb Telescope may have captured calls all of that into question. The recurring diffraction patterns hidden within the galaxy cluster imagery don't just hint at extra dimensions, they suggest that our known framework of spacetime is incomplete. It's not just that there may be higher dimensions, it's that they may be inter. One of the most deeply held truths in physics is that nothing travels faster than light. It's the universal speed limit, the rule that keeps causality intact and time flowing forward. But according to some interpretations of the new Webb data, that rule may not be universal after all. When light is observed through gravitational lensing, we expect distortions. But the distortions captured in the Able 2744 images are asymmetrical, inconsistent with what we understand from general relativity. Some quantum physicists now suggest that what we're seeing isn't light bending, but light slipping, moving through regions of spacetime where the structure allows it to accelerate through geometric shortcuts. If that's true, then the idea of a multiverse, of quantum tunneling across branes, of reality not being flat but folded, becomes more than science fiction. It becomes mathematically plausible. And suddenly, what we call light speed is no longer the limit of motion, but the limit of our perception. James Webb may have shown us that we're not just trapped in 3 dimensions, we're trapped inside a misunderstanding of what dimensions are. While scientists scramble to verify and replicate the Webb findings, the philosophical shockwave is already spreading across the globe. Universities are rewriting lecture plans. Thinkers are re-examining the fundamentals of consciousness, time, and what it means to exist. Some have compared the moment to the Copernican revolution, when we learned we weren't the center of the universe. But this is bigger. Because now, we're not just questioning our place in the universe, we're questioning whether we're in the right universe at all. Cultural leaders, philosophers, even theologians have entered the conversation. What does it mean if our reality is not the base layer of existence? Are we the cosmic mainframe, or just one simulation in an endless cascade of nested realities? And if there are higher dimensions, structured and active, what role do we play in them? Are we blind passengers, or accidental observers? These aren't questions from science fiction novels anymore. They're being debated in academic halls, government panels, and late-night newsrooms. And it all started with an image. Just one. From a telescope that was never built to find anything like this. Perhaps the most poetic part of all this is that the James Webb Telescope, an instrument built to study the first stars and galaxies, has accidentally stumbled onto something far more profound. It was designed with rigid parameters, trained to capture light in the infrared spectrum, optimized for predictable cosmic structures. And yet, through its sheer sensitivity and precision, it became a rebel, a machine that, in following its programming flawlessly, broke free from its design. Webb didn't discover alien life. It didn't find a wormhole. But it may have done something even more revolutionary. It forced humanity to reconsider the canvas itself, the structure beneath space, the rhythm beneath time, the very fabric that holds our reality in place. And it did it silently, without flashing lights or dramatic signals. Just pure data, cold, mathematical, unmistakable, the kind of data that rewrites textbooks not one page at a time, but from the cover inward. And now the world watches as physicists, philosophers, and dreamers alike race to answer a question we never expected to ask this soon: what did the universe just show us? And what do we do now that we've seen it? We built the James Webb Space Telescope to answer questions about our past, to see the first light of the universe, to understand how galaxies formed, how stars died, and how planets were born. But in doing so, we may have uncovered something we never expected, a crack in the mirror of reality itself. The images we captured weren't just beautiful. They were impossible. They revealed not just galaxies and nebulae, but fingerprints, subtle, precise, recursive patterns that may belong to structures beyond our comprehension, extra dimensions, hidden frameworks, forces that don't belong to our three-dimensional logic. Webb didn't just show us the universe. It revealed that what we thought was reality might only be a layer of something far more complex.